Hi, this is Sung and I'm the Principal and Director of Sky Academy, and in this episode what I want to be doing is continuing on our work with multiplying and dividing surds, right? And look at another type of problem that you might get involving multiplication and division, and that is multiplication and division using the distributive law. Right? And I want to go through the distributive law with you. So for example, you see it in algebra, okay? Or you've seen it in algebra, and if you haven't, you'll see it in future episodes. But basically, I want to introduce you to it now. If you've got a number multiplied by another, the sum or the difference of another set of numbers inside a set of brackets, you basically take this number and multiply each of the terms inside of it. So A times B is AB, A times C is AC. You preserve the sign, okay, and that is how you basically use the distributive law, okay. So let's have a look at this first example. The square root of 5 times the square root of 2 gives you the square root of 10. The square root of 5 times the square root of 3 gives you the square root of 15. And you add them together, okay. That should be a plus. Not a times, you add them together. Okay, let's have a look at the second one, the type of question that you might see. And you may have seen this in year 10 as the FOIL method. FOIL, each letter standing for a different word. F in FOIL stands for front, O stands for outside, I stands for inside, and L stands for the last two. Alright, so the FOIL method, front, outside, inside, last. Alright, so what we're doing is we're multiplying the front two, A times C gives you AC. The outside two, A times D gives you AD. The inside two, B times C gives you BC. And then the last two, B times D gives you BD. Does that make sense? So you're doing the front two, the inside two, the outside two, and the last two. So let's have a look at this example. How would you do it? The square root of 5 times the square root of 7 gives you the square root of 35. Outside 2, last 2, square root of 5 times the square root of 2 gives you the square root of 10, and you're adding the square root of 10 because it's plus. Now, you got the negative or the minus square root of 3 times the square root of 7 gives you minus the square root of 21. The minus square root of 3 times plus the square root of 2 gives you minus the square root of 6. Minus and plus gives you minus, right? None of those can be simplified any further, so we can just leave our answer as a 4-surd sum or a 4-surd expression. Does that make sense? When it comes to doing this one, it basically is another FOIL method question, and the way you do it is it's 2 root 2 plus root 3 times by itself. So basically, when you've got a square, it's like doing another FOIL method question. Front 2, outside 2, inside 2, and last 2. But when you've got a square, what's special is that the inside 2 and the last 2, the product of the inside 2 and the last 2 will be the same. When you add them together, you get 2 lots of the outside 2 and the inside 2 answer. Okay, so let's have a look at this sort of question. 2 root 2 times 2 root 2. Alright, 2 times 2 is 4. The square root of 2 times the square root of 2 is 8. Is another 2. So 4 times 2 is 8. Inside 2 is basically root 3 times 2 root 2 is 6 root 2. The last 2, 2 root 2 times root 3 is another 6 root 2. And the last 2, root 3 times root 3 gives you 3. Okay, so your answer will be 8 plus 3, which is 11. 6 root 2 plus 6 root 2 gives you 12 root 2. Okay? Now, I want to come to the last type of question that you'll get, and that is 2 root 3 plus 1 times 2 root 3 minus 1. Now, what do you notice about this expression and this expression? Right? What you notice is that they're the same expression, except the middle operation sign will be plus in one case and minus in another case. So you've got a plus b times a minus b. And here's something that I want you to note. When you've got that case, these two expressions are what we call conjugates of one another. Conjugate surds. This is the conjugate of that. That is the conjugate of this. And you will need to be very good at working out what is the conjugate surd of another surd, because they will become very important when we do the next episode, which is all about rationalizing the denominator. And I'll give you a hint as to what rationalizing the denominator means. When we do this question, I want you to see how the answer turns out. Okay? How will the answer to this turn out? Will it contain any surds or won't it contain any surds? Alright? And that's what I'm interested in. So 2 root 3 times 2 root 3. 2 times 2 is 4. Root 3 times root 3 is 3. 4 times 3 is 12. 2 root 3 times negative 1 is minus 2 root 3. 1 times 2 root 3 is plus 2 root 3. Plus 1 and minus 1 gives you minus 1. Now, there's a surd component here, there's a surd component here, there's a rational component there and a rational component here. What do you think happens to the surd components or the irrational components? Well, let's see what happens. You got minus 2 root 3 and plus 2 root 3. They're going to cancel each other out, and our answer will be 12 minus 1, which is 11. Okay? Now, I want you to notice that the answer is actually a rational number. Okay? It's a whole number 11. It won't always be a whole number, but it's the whole number 11 in this case. Alright? So it's rational. And when you multiply conjugate surds together, the answer will always be rational. Okay? And that is something to remember when doing that. Okay? Great. Well, go away and practice some of this stuff, and I will see you on the next episode. Thank you very much for watching.